Hey guys, Jake here coming at you with a live math lesson again this Monday night, 5 o'clock Pacific time, 8 o'clock Eastern. Sorry, a couple minutes late this week. Just had to finish getting things prepped. Was having some issues getting it ready. So anyway, we're here just a little bit late. Happens sometimes. But today is December 5th. Today we're going to keep kind of going along the track we've been going along on my channel recently, talking about some pre-calculus topics. Just kind of, doing a little pre-calc review, or, just kind of getting some more people in different maths, interested in my channel and interested in calculus and pre-calc. So today we're going to be talking about quadratic functions. Specifically, we're going to be talking about how to graph a quadratic function, as well as how to find the vertex, axis of symmetry, and x-intercepts of quadratic functions. We're going to be going through a few different examples of doing this same type of problem, but the examples are a little bit different. They kind of show you a couple different categories that these problems can be in, and how you can deal with those different things. So I think there'll be a helpful kind of variety of problems to see on the topic of quadratic functions. As always with these live streams, if you do have any questions along the way, feel free to throw them in the live chat. Even if they're off topic, I definitely am happy to help address whatever questions I can. Even if they're not even on the topic of math, feel free to throw them in there. I'll do my best to answer whatever questions you got. But let's go ahead and jump into it. So like I said, this is the problem we're going to start with. This is basically the type of problem we're going to be doing throughout this live stream. We're going to sketch the graph of the quadratic function, identify the vertex, axis of symmetry, and x-intercepts when we have the function f of x equals 16 minus 1/4 x squared. So before jumping into how to solve this type of problem, I want to just take one quick second to point out different formats that a quadratic function can be in. There's basically two main kind of forms that a quadratic function can take. And maybe you've seen these before, but basically they could be either y equals ax squared plus bx plus c, or y equals a times x minus h in parentheses all squared plus k. So these are kind of the two main forms. One thing I kind of want to point out here, just terminology of what these are called. The way I learned it is a little bit different than some textbooks, so that there's a little bit of a discrepancy in the way that different textbooks describe these different forms. The way I learned it was that this first one here, ax squared plus bx plus c, was considered standard form. And then this one down here is considered vertex form. A times x minus h all in parentheses squared plus k, I learned was vertex form. Some textbooks, though, like the textbook where this example problem came from, considers this to be standard form, and it doesn't really give a name to what this first one is. So just something to kind of keep in mind. I am going to mostly be referring to this first one as standard form and this second one as vertex form, because I think the names make a little bit more sense personally. And that's the way I learned it. So maybe that's why I think they make a little bit more sense. But just be careful to kind of cross-check this to how your textbook or your teacher or professor has talked about different forms of quadratic functions, and make sure you know how the terminology I'm using kind of corresponds to the terminology that your class uses. So just be careful of that. In this example we have here, we have f of x equals 16 minus 1/4 x squared. This doesn't exactly look like either one of these options. But we can somewhat easily kind of rearrange it to put it in a form that looks like either one of these two options. So that's generally how I would recommend starting out these problems. There's kind of a nice little shortcut way to figure out the axis of symmetry and the vertex of any quadratic equation, whether you have it in this standard form or vertex form. And I'm going to be talking about how to do that, obviously, but you typically want to basically rearrange whatever quadratic function you're given into one of these two forms in order to do this type of problem. That's kind of your general rule of thumb. Personally, I like working with the vertex form more just because it's a little bit easier to graph it, to graph a function that's in this vertex form. However, there's a lot of cases where you're given something that you can get to this standard form here, and it's really not that much more difficult, honestly. So in this case, really what you always want to kind of do, obviously you have your x squared stuff going on kind of before your constant terms out here at the end. So in this case, we have a constant term and then an x squared term. Probably the best way to start would be to just kind of rearrange these terms. We're not really changing the equation at all. We're just writing the addition of these two terms in a different order. So negative 1/4 x squared plus 16 is the same as 16 minus 1/4 x squared. And now we can kind of compare this to either one of these two forms here. So you can see that we have basically, well, let me just kind of talk about this in two different ways real quick. We can either say that we have negative 1/4 x squared plus 0x plus 16. And you can see in that case, it's pretty easily comparable to this form, right? Where we have a is negative 1/4, b is 0, c is 16. Or we can write it in this form where we have basically a being negative 1/4, the x minus h being x minus 0 all squared, because x minus 0 is the same as x minus 0 squared is the same as x squared, and then plus 16 being our k value. So both of these equations that we can kind of get it into these two different formats, these two equations are exactly the same. If we simplify them, they both simplify back to what we had here in the last step. So we can kind of proceed from either one of these two spots, basically. So I'll just kind of quickly touch on how to do both. Just kind of circling back to what we're looking for here, we want to identify the vertex and the axis of symmetry and the x-intercepts. So the vertex is generally going to be the place that's best to start. Once you figure out the vertex, the axis of symmetry is pretty easy to figure out from there. So just to kind of quickly talk about both of these types of forms we can use here. If we get it into this standard form, the ax squared plus bx plus c, we can find our vertex simply by saying it's always going to be negative b over 2a. So negative, in this case, b is 0. So negative 0 over 2a, 2 times negative 1/4. And if we were to simplify this, 0 divided by any number is 0. So our vertex, or I'm sorry, the x coordinate of our vertex. So basically the x coordinate of our vertex would be given by this equation. So it's going to be 0. Okay. And then from there, what we can do is we can just take x equals 0, plug it back into this equation. So that would be negative 1/4 times 0 squared plus 0 times 0 plus 16. And simplifying this down, this would just be 16. So our vertex would be at an x coordinate of 0 and a y coordinate of 16. Okay, so that's how we can do it from this kind of standard form. From the vertex form, the reason I like the vertex form more is once you get it in this vertex form here, it's very, very simple to see where the vertex is, and that's why it's called the vertex form. The vertex is always just going to be at hk for whatever h and k value you have plugged into your formula. So in this case, it's 0, 16, because we have 0 right there, negative 6 or positive 16 right there. So you can see in both cases, we got the same vertex, 0, 16 for both, but we just kind of used the different formula depending on if we had it in this standard form or in this vertex form. If you're in this standard form, you just use negative b over 2a. If you're in vertex form, it's just hk. Negative b over 2a for the x, and then find the y from there, I should say. So that's why I personally like the vertex form a little bit more, just because it's in a form where it directly tells you exactly where the vertex of the quadratic function is. So from the vertex, if we now want to look for the axis of symmetry, that's really just going to occur at whatever the x coordinate of your vertex is. So the axis of symmetry is just going to occur at x equals whatever the x coordinate of your vertex is. So x equals 0. Okay, and then that's always going to be the case for any quadratic. Once you find your vertex, the axis of symmetry is just that x equals whatever the x coordinate of your vertex is. Okay, so now we need to find the x-intercepts. So to find the x-intercepts, all that really means is where your y value is 0. So to figure that out, all you really have to do is set your equation equal to 0. You can use any of these three kind of versions. Whoa, did not mean to do that. You can use any of the three versions of our equation we have here. So we can use back, or I guess in this case we have 4. We kind of rearranged it into a couple different forms. We have those, and then we have these as well. So any of these should give you the same thing, right? All 4 of these equations that I've circled here in yellow, they're all equivalent equations. So really any of them we want to use, I'll go ahead and just go back to the very beginning one, the one that was given. And we just set this whole equation equal to 0. So we'll just have 0 equals 16 minus 1/4 x squared. And then from there, you basically just have to solve for x. So we'll add 1/4 x squared to both sides. Okay, because that'll cancel with that. Then we will times both sides by 4. (16 times 4 would be 64. And then we will take the square root. We actually have to take the positive or negative square root of both sides. So that'll cancel with the squared. And we get x equals plus or minus square root of 64 is 8. So plus or minus 8. So basically we have 2 different x-intercepts at x equals -8 and x equals +8. So real quick, just to kind of point out, whenever you take the square root of both sides of an equation like this to cancel out something squared and solve for that thing, you always need to take the positive and negative square root, because if we kind of go back, back to this step here, if we plug in -8 for x, so we get -8 squared gives us +64. +8 squared also gives us +64. So just make sure you're taking the plus or minus square root on a step like that. So that's really all the 3 things we had to find there. Then we have to sketch a graph. So we're not quite done yet. We do have to sketch a graph. Basically to do this, okay, so to do this, we have a few different kind of pieces of information here. 1, 2, let me go ahead and just label my axes real quick. Actually, let me spread that out a bit. Okay, so I've labeled my axes counting by 2s. Basically, we know that we have a vertex at 0, 16. So that's generally the easiest place to start, is just by graphing the vertex of your quadratic. So that's at x equals 0 up to y equals 16. So that'll be right there. Then we know that we have an x-intercept at -8 and at +8. So that'll be -8, +8 as our x-intercepts. And then since we had an a value, basically our x squared term had a negative coefficient, that tells us that it's going to be a downward facing parabola. So essentially we just kind of draw a parabola from that vertex going down through those x-intercepts. Wasn't a great drawing. We know we should have an axis of symmetry at x equals 0, which is basically just the y-axis. So it should be symmetrical. Obviously, that's not a perfect drawing, but it's a good enough sketch to get the idea. So that should be it for that first problem. I'm not seeing any questions in the live chat. As always, if you do have any questions, feel free to throw them in the live chat as we go, but let's keep on rolling. All right. So this problem, they tell us, or sorry, just to reiterate, same problem we just did, sketch the graph of the quadratic function, identify the vertex, axis of symmetry, and x-intercepts. So in this example, we are given our quadratic equation, our quadratic function, and it's already in the vertex form. So again, the vertex form is y equals a x minus h in parentheses, all squared, plus k. So we've already got that nicely in this form, where basically we have an implied a value of 1, and then x minus 6, so x minus h all squared, plus 3. So we can see, without even having to rearrange our equation, basically we can consider 1 our a value, we can consider 6 our h value. So keep in mind, it is x minus 6. Since our kind of general form is x minus h, our actual h value is positive 6. And then our k is 3. So h is positive 6, k is positive 3, a is 1. So really all that means is, since this is the vertex form, it's already in vertex form, this tells us right away our vertex is at hk. So it's at 6, 3. So the vertex, once you get it in this vertex form, the vertex will always be at the point hk. So in this case, it's just going to be 6, 3. Okay. So once you find your vertex, your axis of symmetry comes easily from there, because it's always just going to be at x equals whatever the x coordinate of your vertex is. So x equals 6 is our axis of symmetry. And then we need to find our x-intercepts. So to find the x-intercepts, what you need to do is take your equation and set it equal to 0. So we just get 0 equals x minus 6 squared plus 3. Because think about what an x-intercept is. It's just the place, basically, where your function intersects with the x-axis. The x-axis always has a height of 0. It has a y-coordinate of 0. So if we're plugging in 0 for y, basically 0 for f of x, and then solving for x, that should tell us what x values give us the y value of 0, which is where our function should intercept with the x-axis. Okay, so now we pretty much just need to kind of solve this and figure out what x values we're going to have x-intercepts. So to do that, we're going to just start kind of moving terms over, get x all by itself. So minus 3 from both sides. And then take the square root of both sides to cancel this squared. And now notice what we're doing. We're taking the square root of -3, of a negative number. So in this case, since we have to take the square root of a negative number, you can't do that. You can't take the square root of a negative number. That's basically against the rules of math. So that tells us that this equation has no solutions, and therefore this quadratic function has no x-intercepts. So we know that we are going to have, now we need to sketch this. Before we do jump into the sketch, though, if you are getting some value out of this video, do me a huge favor, hit that like button. And while you're down there, hit that subscribe button and that bell icon too. If you're finding this video helpful, I'm going to have a lot more videos helpful also, very similar to this one. So hit that subscribe button. We'll keep crushing it all term long in pre-calc or calculus, whatever math you're taking. But let's go ahead and go on to the sketch. So basically at this point, we have figured out where our vertex of our parabola is. We figured out that it has no x-intercepts, and we have figured out one other, well, we haven't figured out one other thing, but one other thing that we should discuss before sketching our graph this a value is positive 1. So what that a value tells you is basically, well, two kind of key things there. If it's positive or negative, that gives you some information. That tells you what direction the parabola is facing. If a is positive, it's going to be an upward facing parabola. So it's going to be like a smiley face shape. If a is negative, it's going to be a downward facing parabola. So like a frowny face shape. So since a is positive 1, that tells us it's generally going to be in this kind of a shape, like a smiley face. Okay. What a really does is it stretches your parabola, like kind of stretches it taller and skinnier, or kind of squishes it down and makes it like shorter and fatter kind of. So an a value of 1 tells us it's not really being stretched. Basically, it'll look exactly like the function of y equals x squared, except it'll just be moved to the left or right or up or down. But it's going to be not stretched in any direction. So what we know is kind of the general shape of our parabola based on our a value. We know the vertex is at 6, 3, and then it's not going to have any x-intercepts. Well, let's think about that, because our vertex at 6, 3, if this is x equals 6, this is y equals 3, our vertex being at 6, 3, so x equals positive 6, y equals positive 3, and then knowing that our parabola is generally kind of going upward like this, it makes sense that there's no x-intercepts, right? Because the lowest point is the vertex. It's only going to go up from there. It's never going to intercept with the x-axis down here. So it definitely kind of aligns our vertex and kind of the general shape of our parabola facing upward align perfectly with the fact that we found no solution to this equation, meaning no x-intercepts. So that would be, you may want to put a little more detail in labeling your axes and all that, but this should be a pretty good sketch showing us what this quadratic function should look like. All right. Still not seeing any questions in the live chat. If you do have any along the way, feel free to throw them in there. But let's go ahead and get into this third example here. Sketch the graph of the quadratic function, identify the vertex, axis of symmetry, and x-intercepts. So now this example, we are given a quadratic function, which is in the kind of standard form. And again, like I said before, depending on what textbook you're using, they might define standard form differently than the way I'm defining it. But the way I learned it is standard form is this ax squared plus bx plus c. Some textbooks consider what I have been calling the vertex form to be standard form. So be careful with that. Make sure you check that in your textbook. Check that with your teacher. Make sure you know which kind of terminology you should be using in your class. But it's in this form, this ax squared plus bx plus c form. Now, what we want to do is kind of think about what our a and b and c values are. Well, the a is always going to be whatever the coefficient of your x squared term is. So in this case, we kind of have an implied a value of 1. Whenever there's no coefficient in front of your x squared or your x term, you can just assume that the coefficient is 1. Then we have a b value of 2, and then we have a c value of 1. So once you've kind of identified that you have it in this ax squared plus bx plus c form, identified what your a, b, and c are, you can pretty easily find the vertex from there. All you really have to do is just use the equation, basically, that the x-coordinate of the vertex of a quadratic equation, quadratic function that is in this form, is just going to be negative b over 2a. So in this case, negative 2 over 2 times 1. Now we can just simplify that down. Negative 2 over 2 times 1 is 2. Negative 2 over 2 is negative 1. So the x-coordinate of our vertex is going to be x equals negative 1. Now to find the y, all we have to do is take x equals negative 1, plug it into our equation here. So we're going to get y equals negative 1 squared plus 2 times negative 1 plus 1. Okay, so whenever you're plugging in an x value into an equation like this, you're basically just replacing all the x values with whatever this number is. And then make sure you put it in parentheses like that. Just kind of as a first step, I think it's generally a good idea to just literally take your x out and put in whatever number you're trying to put in there and put it in parentheses just like I did here. And the reason that's important is the negative sign is going to behave differently if you're putting in parentheses or if you're forgetting those parentheses. Because the squared now, if you have -1 all in parentheses squared, like we have here, -1 times -1 is +1. So anything squared is just that number times itself. So this is like -1 times -1, which is +1. Okay. If you forget the parentheses and you just write -1 squared, the squared is only being applied to the 1. 1 squared is 1, so you still would have -1. So the parentheses do make a difference here. The sign is going to be different if you forget to write those parentheses. So just be careful with that whenever you're plugging x values into a function like this. Okay, then we're going to have 2 times -1, which is -2, plus 1. One plus -2 is like saying 1 minus 2 plus 1. 1 minus 2 plus 1 is 0. 1 minus 2 is -1. -1 plus 1 is 0. So our x coordinate of our vertex is -1. The y coordinate of our vertex is 0. So our vertex is at -1, 0. Okay. From there, we can talk about our axis of symmetry. Once you have your vertex, your axis of symmetry is always just going to be x equals whatever the x coordinate of your vertex is. So x equals -1. And then x-intercepts. So again, just like we've done in prior examples, to find the x-intercepts of a function, you just set it equal to 0. So we're just going to get 0 equals x squared plus 2x plus 1. And then solve for x from there. So probably the best way to solve this one would be to factor it out. This can be factored out as x plus 1 times x plus 1, because this would FOIL back into x squared plus 2x plus 1. And then we can set each of these parts equal to 0 separately. Because if either factor is 0, 0 times any other number is also 0. So of course, these two equations are exactly the same. So we really just need to solve one of them. We get x equals -1. So basically, we only have one x-intercept in this case. This one will also give us x equals -1. We only have one x-intercept at x equals -1. And we know that our vertex is at -1, 0. So now to sketch all this, we can start by just drawing our axes here. So like I said, our vertex is at -1, 0. So we go to x equals -1, y equals 0. So our vertex is right there. And then we have only one x-intercept at x equals -1, which is exactly what our vertex is. So that's what we would expect whenever we're only getting one x-intercept on a quadratic function. That tells us basically that our vertex is on the x-axis. So just kind of a shortcut there, going back here, as soon as we found that our vertex occurred at a y value of 0, that tells us that our vertex is sitting on the x-axis. If the vertex of a quadratic function is sitting on the x-axis, that means that's the only point where it intersects with the x-axis. So that's kind of a shortcut. We didn't really need to do this kind of solving for the x-intercept right here, because our vertex actually told us that we only had one x-intercept and that it was at x equals -1. So then from there, we want to just kind of think about what direction this parabola is going to go. Is it facing upward or facing downward? Since our a value is +1, it's a positive number. That tells us it's facing upward. So it's just going to go up. And that's not a great sketch because it should go through this point 0, 1 right here. I kind of missed the mark there, but that should be a pretty good sketch of our quadratic. And then we definitely want to make sure to, label our axes and all that, make sure it's correct there. But that should be a pretty good sketch. So that's about it. If you did get some value out of this video, do me a huge favor, hit that like button down below, hit that subscribe button and that bell icon while you're down there too, so we can keep crushing it all term long in pre-calc or calculus. Not seeing any questions in the live chat, so we'll go ahead and wrap things up there. And I'll be back next Monday night, 5 o'clock Pacific time, 8 o'clock Eastern for another live stream. I know finals are coming up, so be sure to come with any questions you got. On topic, off topic, I don't care. Come with whatever questions you got. We'll do our best to do some finals prep next week. And so you can finish the term strong and go into winter break feeling pretty good. So thanks for coming. See you next week.